Assalamualaikum warahmatullahi wabarakatuh, and hi to everyone. My name is Mariam from Chemical Engineering Faculty. Would like to present vegetable oil based epoxidized oil, a sustainable approach. Before that, please like and share and do subscribe my YouTube channel, Mariam Masrufa. Alright, here we go. Vegetable oil based epoxidized oil, a sustainable approach. Okay, palm oil tree has been introduced to Malaysia in early 1870 for economic purpose. And in 1970, it is become commercial plant as economic purpose by government and also encouraged for increasing the industrial of refining crude palm oil for export. And as we know, Malaysia is fulfilling the demand of palm oil more than 150 countries worldwide. And the Malaysian palm oil production is significantly increased over the years. Okay. Now we look on the production of crude palm kernel oil for the month of December. Okay, as we know, usually during I think on February until November, usually there is a huge of production, and usually we slow down to December and January due to the flood and so on. So we can see in 2020 there is 2,203,313 metric ton, and while 2021 there is 2,049,435 metric ton, and actually it is quite a lot. Okay. So why it is a sustainable approach? As we know that palm oil is a renewable resources, and it also can reduce the large amount of carbon produced from industry. It is an eco-friendly. Epoxidation is a result of extraction of palm oil to produce epoxidized oil throughout chemical reaction and can be classified as biodegradable material. So here, metal catalyst is an epoxidizing agent with regards to the creation of environmentally friendly process. Okay, we use in situ epoxidation of vegetable oil generate performic acid from a reaction of carbolic acid in the presence of catalyst with performic acid. Okay, for the research methodology, materials that we use: aqueous for performic acid 85%, hydrogen peroxide 30%, catalyst sulfuric acid 95%. And other material we use a crystal violet, hydrogen bromide 48%, glacial acetic acid 100%. Okay, for the experimental setup, okay, first thing for the step 1, we be preparing material, performic acid, hydrogen peroxide, oleic acid with a standard molar ratio of concentration. Step 2, catalyst, formic acid, oleic acid added simultaneously into magnetic stirrer mixture and fixed feed speed at 300 rpm and desired temperature which is constant. And step 3, add hydrogen peroxide, drop into the mixture. Okay, this is the setup, the parameter setup. We have temperature, catalyst speed, range of 75, 0.5 gram for catalyst, and speed 300 rpm. And the kinetic mechanism of epoxidation vegetable oil is described by, as we know, performic acid, hydrogen peroxide become performic acid plus water, and also performic acid plus unsaturated fatty acid become epoxy. Alright, we go for the result and discussion. Okay, we look at the percentage of RCO different based on different performic acid molar ratio. Okay, it shows on the increasing of RCO percentage level before it's dropped to another level. The presence of hydrogen peroxide is important to form the epoxide and can be used in the hydrolysis process, which react with water to produce DHSA. And from the previous study stated that in a water solution, the concentration of hydrogen peroxide can be increased because the fact that water freezes and evaporates quicker than hydrogen peroxide, which means that the higher reactivities can be achieved if the concentration of hydrogen also increase. Okay, let's look on the reaction rate determination. We have heterogeneous and homogeneous catalysts. And okay, this is the best fitting value for the parameter used in kinetic model. Okay, and we use a kinetic model in situ epoxidation by homogeneous catalyst. Look at the oxygen content. Okay, the highest of oxygen content before it's react to slow down. Okay, epoxidation for vegetable with performic acid is way faster than the one with peracetic acid. The epoxidation of palm oil is an example of reaction with many stages, and as the result, modeling method is required to solve this system in the way of minimize the numbers of parameters. As I shown on the figure 2 and figure 3 represent the impact and concentration of reaction at the beginning values because of the epoxidation of palm oil. And per hydrolysis and performic acid breakdown process occur during the manufacture of periboric acid using formic acid and hydrogen peroxide. And when the gases break down, produce spread to the gas phase, it is an exothermic liquid phase reaction system. And by using ordinary differential equation, ODE45, to analyze the experiment data, can be determined the kinetic optimization value. And it can reduce the association between the proportional factors and the activation, the energy during the parameter supplied to the bare minimum. And for organic phase, the model tend to underestimate the concentration of oleic acid in the intermediate and epoxidized compound. And this is related to accurately estimating ring opening degradation when the value of epoxy is constant and compound the desire to degrade it are added. So as a conclusion, epoxidized vegetable oil have increased extraordinary significant as late of because the way that they are gotten from inexhaustible and reasonable asset, and this manner so as natural inviting. So that is all from me. Thank you.